Hello and welcome to my talk about incremental migration to software product line engineering. My name is Sten Grün. I work at ABB Corporate Research Center in Germany, a group of software architecture, and this is a joint work with colleagues of mine, Andreas Burger and Julius Rückert, who work at ABB Corporate Research, and also with Thomas Kantonen, who works at ABB Drive Products in Helsinki. Before we start, let me spend a minute on explaining our application domain. So in this paper, we work with the domain of low voltage frequency converters, or so-called drives. So this is actually an embedded device which controls electric current and voltage to speed up and control an electrical motor application. So typically you're interested in controlling rotation speed or torque, and you can use these devices throughout the industry, for instance, in applications in, let's say, water and wastewater treatment, or in air conditioning systems, or in machinery applications like cranes. So this gives us already a range of variability in our systems, but also we do have another dimension of ranges, which is not only the application, but the used voltage, the used current, and also the used environment like network connectivity. And again, low voltage drives are just a fraction of our bigger ABB's drives portfolio. So as already mentioned, we are, I guess, as all industries nowadays, tackle challenges with digitalization and IoT, which require higher complexity of the firmware, such that new features can be included, and also the need of customer-tailored products. So you need to tailor your firmware not only to specialized application, but also maybe even on OEM or single customer needs. So with this complexity increase, we need a strategy for systematic reuse and complexity management. So this is actually a very nice application where SPLE can help us to manage this variability. So we decided to try out SPLE methodology on our firmware application, which is running on the Drive platform. And this is an embedded system running on top of the real-time operating system. It has a few millions of embedded C++ code, and we also have an embedded custom toolchain. We do have multiple software layers in our system, and variability is hidden in the lowest layer. So this is the hardware abstraction layer, and also on the customer layer, which we call application layer. So their application features like PID control or pump monitoring are hidden. And another topic here is that the system is being continuously developed and continuously improved in an agile manner. So the system is continuously under development. So at first we tried to understand the status quo of our system based on the virtual platform paper published by Antikiewicz in 2014. And we evaluated that our system is somewhere between level 2 and level 3 on this virtual platform levels. So we do have already modularized features to some extent. They are also pluggable, so you can include and exclude them. And we also decided to model features as customer visible features. So here we primarily address the issues of things which are being visible to customer. We do also use preprocessor flags, so mostly we use compile time variability binding, and the project configuration or feature configuration is currently hidden within the toolchain. So the idea of the demonstrator would be to make the first step towards the level 4 and to create a feature model for the project, also which is built into a commercial SPLE tool. To understand which stakeholders we do have in our SPLE system, we conducted a number of workshops and discussions. And in these discussions, we identified 3 main roles of users of the feature model and the SPLE system itself. On one hand, we have product manager, who takes care of defining features. So please remember that throughout this paper, we call feature an externally visible feature. So this is something which creates customer value. So the product manager defines those features, they assign them to the product variants, so they're focused on the problem space if we speak about the feature model. On the other hand, we have a domain architect who is actually in charge of planning the implementation of the feature. So he is in charge and working on the solution space of the feature model, and he makes sure that the features which are included by product manager are matched to the software architecture. The third role is the role of the software developer, who is the so-called active consumer of the feature model. So he's actually interested in making sure that the decisions are understood by him. So he wants to have a big picture and understand why is a particular feature mapped to a particular variant. So surprisingly for us, we actually found out that there are some benefits indicated by our stakeholders. So mostly synchronization with experts and always up-to-date specification. And these benefits were actually located as something which can be used even in a non-invasive way. So we had a big discussion how we should introduce an SPLE system into running development process, but actually we were able to step back from this discussion and start or plan introducing a SPLE system stepwise in a non-gradual way. I think this was for us, that was a real breakthrough in actually, convincing our stakeholders to give SPLE a try. And that's why we drafted out an incremental strategy to introduce SPLE in a company or in a development cycle. So, and this is the proposed 4-step non-invasive migration process. We start with 3 non-invasive steps, and only the last step is invasive. With non-invasive, we mean the truth of the system configuration is still hidden not in the feature model, but in the build toolchain. We start with usage of SPLE as a better documentation, as a model-based documentation. So here we need a high fixed effort, reading through the documentation, reading through internal documents to build up the feature model. But these costs are typically fixed. In the next step, we establish synchronization means such that the actual build system and the build configuration and the feature model do not disconverge. Therefore, we need technical means and first organizational efforts to synchronize burst worlds. The third step would be the simulation, so building firmware and building build artifacts. So all models need to be consistent, but we just ignore the artifacts generated by the SPL system and take our original ones. And the last step would be then to switch over and to use SPLE system as the source of truth. So in the demonstrator, I'm going to describe in the next slides, we have reached stage 2, so the synchronization stage, and we have done the first steps to test the SPLE on 2 products regarding the simulation step. So here we generated artifacts using the 150% approach. So this is the overview of our demonstrator. We have chosen a subset of 12 products to model a representative system. The feature space or the feature model consists about 70 customer-facing features, and this is what you typically see. It's a tree with a low depth of maximum 4. And we have connectivity between the feature model and the family model in both directions, right? So selecting of a control mode 1 will imply a flag, and also enabled of control mode 1 will create a recommendation or a clue that the control mode 1 has to be selected on the feature side. On the solution space, we have modeled our preprocessor flags, mostly covering more than 80 of them. So we take a decision to make here a sparse model as possible to prevent over-engineering. And in addition to flags, we also modeled parts of our internal menu-based system, so visibility or availability of menu entries, which I cannot show here in this presentation. So having built up the problem and solution space in pure variance tooling, we then made a couple of custom plugins for the pure variance tool. So we built up some Java transformations to generate 100% artifacts out of templates for our custom build toolchain. We used some custom feature types and built-in feature properties, which are provided by pure variance. And we also have written a couple of plugins to simplify model maintenance. So for instance, we built a log scanner and wizards or quick fixes, which system architects can use to fix up or to establish the consistency of the family model. So in the CI integration, this is the next step for the synchronization step. We have built also a couple of plugins for Jenkins for our continuous build toolchain, where we're actually automatically scanning and comparing the output of the build logs, so which are mostly consisting of the active build flags and the family model of the feature model. So also active build flags that should be activated. And in case there is a discrepancy, the build is failing, and then the software architect is alarmed to fix up the model, which he can do with the plugins. To summarize my presentation, let us scroll through lessons learned. So we learned that non-invasive SPLE brings benefits while introducing. So even without a hard break of a development system, you can have benefits like improved stakeholder communication, improved documentation, and so on. So one key was here inclusion of product managers. The second key was having a roadmap of sequential non-invasive introduction using commercial tooling. On the other hand, if you use commercial tools, you have to watch out for the APIs and the extensibility, since this might be needed if you would like to adapt them to your custom brownfield environments. Open challenges are still remaining, so we need to cope with versioning of the feature model and include features. We need to cover aspects of our solution space like test system, which hasn't been covered yet. And we need, for instance, to define a process of using the SPLE tool. We need to assess the role-based control options, which are available for pure variance tooling. Once we have that, we plan to make further steps on the SPLE adoption and then collect data, costs and benefits and present them in a quantified way, and also to weight them in terms of return on investment. So here, thank you for your attention, and please contact me for further information.